The next sound we'll try to build an operator using additive synthesis is a pad. And so I've loaded a sound here. And so I'll play it first so you can hear what the sounds sound like, and then we'll try to build it from the ground up. So let's break down this patch a little bit. First thing I'm going to do is, this patch does use an LFO and a filter. I'm going to turn them off for right now, but we will come back and activate this, and I'll talk you through this. So there's some subtractive synthesis with the filter, as well as we're adding an LFO to that. The first thing we should do is look at the algorithm in the global settings, and so we are set to additive synthesis. Everything else in the middle here is set to default. In terms of voices, I have it set to 6 voices. I have retriggering enabled. I do have interpolation activated. I'm not activating anti-aliasing, and all of this is set to the defaults. So again, you can play with panning and random panning a little bit if you want to. That can be kind of sometimes nice in a pad. Of course, we can always add this later with an effect. Let's take a look at the oscillators themselves. So look at oscillator A. And in fact, if I just turn off the other oscillators, so here's just operator A on its own. So you can see there's quite a sustain. I've released the notes and they're still sort of ringing. So I've got 0 attack. And you'll notice that there's this funky little curve here. So the way we got this is if we adjust things like decay and sustain and release. So for instance, there's my decay, right, which was set at 600 milliseconds. But my sustain, right, is also set to 0 dB. But my peak, that's this number. So watch how this changes. So, right, so this is part of the attack, right? And so what we did is there's 0 attack, but my peak is very, very low here. I think it's set to -36. So there we go. My release time is set to 11.4 seconds, which is a long time, right? So, and that's fine, because with a pad, we want the pads to we get a sweeping kind of sound and just sort of ring for quite a long time. So it's a very reverberant kind of sound. And so what we're going to do then, and the last thing is for the waveform, and you can experiment with this a little bit. We have this set to a sawtooth with 32 harmonics. Let me in fact change this to a sine wave. So pretty boring really. Here's a saw 4. And then a saw 8. A saw 32. And a saw 64. So not a lot of difference there, but I'll just go back to the saw 32. And that's it. That's all we need to really worry about for this part of the patch. Now, in terms of adding B, so let's take a look at B and compare B to A. And I'm going to turn on B. And you'll see, actually, if I click through, so I'll turn all of these on, or if I just sort of click in them, you'll see that they all have basically the exact same settings, except for some fine tuning going on here, and as well as what's happening over here in the wave area. So notice that I'm using a slightly different, there's something funny going on here with the way the waveform looks in these patches, or these oscillators here. And so let's kind of dissect this a little bit. So what we can do is when you're building this is if I'm in oscillator B, all you have to do is, for instance, let's say we're in the envelope area here and I right click, I can just copy the oscillator from A and just do that for each of these. Okay, so if I just grab this and then copy it from A, now what I can do is I can just make a few little adjustments. And so the adjustments we want to make is we're going to just adjust the fine tuning a little bit here. I'm going to set this to about 6 or so. Now you'll notice if I'm moving this that sometimes it's really hard to get it on a particular number. You can see it's skipping. And so once I have it activated, I'm moving the knob. If I hold down the shift key, then it'll go 1 digit at a time. I'm going to get this down to like 6. So there we go, there's 6. And then the other thing we're going to do is we're going to, like if we look at the waveform here, the sawtooth wave, you'll notice, for instance, if I look at this one up here, that it's just what's called out of phase by 50%. And so I'm just going to, whoops, click on B here. I'm going to click on phase and just hit 50. And so now it just moved the sawtooth wave over just like about halfway. So these two waveforms are out of phase by 50%. And that just adjusts the timbre. We'll talk about this and other kinds of this later on. Sort of the phase of the waveform, depending on what the waveform is, can be really important in terms of how we build sounds and things like that. So again, we're going to do the same thing. So you should copy from oscillator A into C. All right, so we're going to copy, whoops. So the way to do that again is if I go in the envelope area and I right click here, I can just copy all the parameters from oscillator A into C and into D, and that'll copy the envelope and everything else. And then just make sure that for D, what we're going to do is it's using exactly the same waveform. And for C, we're going to use the 50% phased one, right? So A is our normal sawtooth. B has a 50% phase with the same sawtooth 32. C has sawtooth 32 as well, same as B, 50% out of phase. And D is, whoops. And then D is exactly like the first one, so 0% phasing, but still the sawtooth 32. And they all use the same envelope. And then the only other thing we need to adjust is in the fine tune. B is set to, fine tune is set to 6. Oscillator C, the fine tuning is set to 16. And oscillator D is set to 22. And so what this is doing is they're slightly detuned from one another. If I just play each one on its own, you'll hear a slight change in sort of the pitch. So here's A. So they're slightly detuned from one another. So here's A and B together. So you'll hear a little bit of beating, and then here's C. More detuning, and then adding D. So because they're all slightly detuned from one another, it's really adding sort of a really rich harmonic spectrum of sound. So this is actually not a bad sound. But we can sort of, fine tune the tone by going into our filter. Let's activate our filter. So that's really nice because we filter out some of the harsher frequencies, higher frequencies from the beginning, and then they enter in later. So you can see under the envelope that we've got, in fact, pretty much the same as what I had from the oscillator A. So I've got 0 attack, 0% at the peak, a 9.9 second decay, so pretty long decay. A release time of 28.2 seconds. My sustain is set to 100%. So what you want to do is just copy these parameters for your envelope. In terms of the filter type, we're using the 5th option down here, which is a state variable filter. We have this set so the filter slope is between 12 dB per octave. I have it set to clean. My frequency is set to 130 hertz, and I've got just 20% of the resonance. So you can adjust these and just see what happens. So you find something that you like. And again, to fine tune it, just hold down the shift key and you can get it exactly the way you want it to. And then same with the resonance. Like that's pretty cool too, actually. So I'm actually going to bring the resonance up a little bit. I kind of like that. So, but you can find the right sound for you. Okay. I forgot to mention that in the global settings, I do have my tone set to 100%. You can adjust this too. So we lost a few of the upper harmonics there. I really like those upper harmonics, so I'm going to keep this at 100%. And I do have the volume brought down quite a bit because this is additive synthesis. Each of these is producing its individual tone, and then we're getting these, these resultant, vibratos happening because of them sort of responding, sort of reacting to each other. The different tones, all in, think about two singers singing and one being slightly out of tune from another. We get that kind of beating sound, right? Or when you're tuning two strings on a stringed instrument and one string is slightly out of tune, we listen for those beats. And that's exactly what we're doing here in this oscillator, or with these oscillators. The last component here is this LFO. So in this particular case, the LFO, we're using a sine wave. I have retrigger activated. I have a rate of about 79.5. You can change this as you want, and the amount is just 15%. So I'm going to change both of these, and we'll hear what the difference is. The LFO is affecting all four of the oscillators, not the filter. I have a attack of 0 milliseconds, a decay of 1.44 seconds, 0.0 dB at the peak, 60-second release time, so long release time, and minus 17 dB in terms of the sustain. So that gives us this envelope. And so here's without the LFO. And here's with the LFO. So it's very subtle. I'm going to increase the amount so you can hear what this really sounds like. Right? So every time it's just like getting this really wide vibrato. I'm going to turn down the rate a little bit. So there I just so if I re-articulate some notes, if I have retrigger on, each note will start exactly the same. The LFO will restart on each one of these, and so that you'll get this sound. You can hear the sine wave there. If I turn retriggering off, what's going to happen is this LFO is going to run independently. It's just going to be running constantly. And every time I retrigger a note, I might be at a different point in the sine wave. Right? So that's cool. Maybe we want that effect, in which case you can keep that. Or if you have retriggering on, each attack will be exactly the same. So you can play with the rate and then also the amount to find what feels right and sounds right to you. If you want to have this kind of crazy pad, right? Or we can really bring this down. So to me, this sounds really crazy and almost drunk. If I bring this down, just adds a little bit more depth to the sound. So that's how we can build a pad using 4 oscillators that are very close in terms of all using basically the same kind of waveform. Some are slightly out of phase. So these 2 are slightly out of phase from A and D, and they're all just finely detuned from one another. They're all using exactly the same envelope. We're applying some filtering to this, as well as the LFO. And of course, if you add some reverb to this, then it'll resonate and ring even more, and you get this kind of cool sound.